Okay, let's talk a little bit about simple machines and mechanical advantage. This is from chapter 9. Um, what do machines do? Important. Machines make work easier, not less. Actually, because of friction, you're actually going to be doing more work, but they make it easier. For example, if we did not have stairs, which are an inclined plane, imagine how hard it would be to get to the second floor. Remember our discussion in class of the rope you would have to climb. However, you don't have to use as much force to go up the stairs, but you have to apply that force for a longer distance. So therefore, you actually do more work, but it's easier. Okay? So the answer to the question, would the work you do going up the stairs be the same, less than, or greater than the work you would do climbing the rope? Okay, in the perfect world, without any friction, it would be exactly the same work. Okay, but in the real world, you have friction as you climb up the stairs, and so you're actually going to do more work than you would just climbing up the rope. Okay, you understand? There's two basic groups of machines. The ones we're going to talk about mostly in this chapter are what are called simple machines. These are machines that have few working parts. There's actually 6 of them, or some people would say there's 7 if you count a gear. But the 6 are pulley, a wheel and axle, wedge, lever, inclined plane, and screw. A pulley might be something as simple as the pulley that raises a flag up the flagpole. A wheel and axle could be a steering wheel on the car. That's a wheel and axle. A wedge could be the blade of a knife or the wedge that holds the door open in the classroom. A lever, a pair of scissors is actually 2 levers that share what's called a common fulcrum. Okay. Inclined plane, we've already said. A ramp, stairs are an inclined plane. And a screw, that's pretty easy to figure out. It's just a screw that holds pieces together. Okay, compound machines, or sometimes they're called complex machines, are machines that are made up of a combination of simple machines. So a bicycle, a bicycle has a wheel and axle. It also has a lever if you look at the handlebar. It has a wedge if you look at the seat. Can opener, that's a complex machine. I see a wedge in a can opener. I also see a wheel and axle. Snowblower. So any complicated machine generally is made up of 2 or more simple machines. Mechanical advantage. Mechanical advantage is basically a way that we can rate machines. They tell us how good the machine is. This really means how many times does this machine multiply your force. In other words, how easy does it make it for you to do the work? Okay. You can calculate what's called the actual mechanical advantage of a machine by using the following formula. Actual mechanical advantage equals the force out, in other words, what force you get out of the machine, divided by the force you have to put into the machine. Sometimes the force out is just called the load or the resistance, and the force in is what you put in, and it's called the effort. Here's a sample problem. Okay. This is an inclined plane, as you can see. Let's just say it's a boulder that we're pushing up an inclined plane. The force that we're exerting on it is called the effort force or the input force. In this case, that's 2 newtons. The resistance is the weight or the load. Force out is another name. In this case, the resistance or the weight of this boulder is 10 newtons. Okay? To find the actual mechanical advantage, in other words, how many times this inclined plane multiplies the force you put into it, you take that force out, or the resistance, and divide it by the force in, or in other words, the effort, which would be 10 divided by 2, which equals 5. So this machine will multiply whatever force you put into it 5 times, or you can lift something 5 times heavier than the force that you're able to exert. Okay? Ideal mechanical advantage. Okay, the word ideal, whenever you see ideal in physics, they're talking about no friction. Okay? The ideal mechanical advantage in this case is found by taking the input distance of a machine and dividing it by the output distance. It does not take into account the friction as you use the machine, and as a result, the ideal mechanical advantage will be higher than the actual mechanical advantage. In fact, an ideal mechanical advantage can be calculated without even using the machine. I'll show you on the next slide. Here's an inclined plane again, okay? We're going to push this ball up the inclined plane. The length of the inclined plane we call the input distance. That's what you would have to push the ball. That's 4 meters. The actual height that this machine actually does for lift the ball for you is only 2 meters, okay? That would be called the output distance. Think of this maybe as one of those ramps for a moving truck. If you had a washing machine, if you were strong enough, you could just lift that washing machine, put it right on the tailgate here, 2 meters high of the moving truck. But if you're not strong enough, you need that ramp with the rollers, and you have to push it a farther distance, but you don't have to exert as much force. We could calculate the ideal mechanical advantage here by taking the input distance, 4 meters, and dividing it by the output distance, 2 meters, and we get 2. That means, ideally, this machine has a mechanical advantage of 2, and it would multiply your force 2 times. Keep in mind, though, we're not counting friction, so maybe it wouldn't multiply your force 2 times, maybe it would like 1.8 or something like that. Okay? Alright, so what we're going to do here, we have some assignments on Edmodo that you're going to do in class, but I also want you to do for homework the worksheet problems on mechanical advantage, and they will be due your next class. Okay? Thanks a lot.